sum on an is convergent, then we have to prove that the infinite sum on an divided by n the power x is uniformly convergent on the closed interval 0, 1. So here we are going to use the Abel's test. So this is the given series which we need to show that it is uniformly convergent on closed interval 0, 1. What Abel's test requires is that to apply the Abel's test, we need to get the product of un and vn, where n is going from 1 to infinity. So for this series, let's take un to be an and vn to be 1 divided by n the power x. So what are the three conditions for the Abel's test? First one is, we have to show that the infinite sum on un is uniformly convergent. Second requirement is that the sequence Vn is monotonically decreasing sequence of positive terms. And then third requirement is that we have to show that Vn is uniformly bounded. Right? So let's go for the first condition. So let un be equal to an, it is independent of x, and Vnx is equal to 1 divided by n the power x. Vn is depending upon x. So the first condition, now what is given to us is that the summation n going from 1 to infinity an, this is convergent. This is given to us, right? So to make use of this, because an is independent of x, that means this series is also uniformly convergent as it is independent of x. For uniform convergence, there exists a natural number n that depends upon epsilon and is independent of the point x. But for the convergence, there exists a natural number n that depends upon epsilon and also the point x. This is the difference between these two. Now, as this an is independent of x, we say that this summation is uniformly convergent. So, as an is independent of x, therefore, the summation n going from 1 to infinity on an is uniformly convergent on the closed interval 0, 1. Then is the second requirement, that the sequence Vnx is monotonically decreasing sequence. What is Vnx? We have taken Vnx to be 1 divided by n the power x for the interval 0, 1. Now in this interval, clearly this sequence is monotonically decreasing sequence of positive terms. Why positive terms? Because x belongs to 0, 1 interval, x is positive, and also n is starting from 1 to infinity, right? So it is a sequence of positive terms. So writing this clearly, Vnx is a decreasing sequence of positive terms on closed interval 0, 1. Right? Okay. Now moving on to the third condition, to prove the third condition, that is Vnx is uniformly bounded. For that, we have to take the mod of Vnx. Now since if I take the mod of Vnx, that is equal to mod of 1 divided by n the power x, then this mod is strictly less than what real number? Now for the closed interval 0, 1, the mod of 1 divided by n the power x is equal to what? If I take x is equal to 0, I am getting mod of 1 divided by n the power 0. So that is equal to mod of 1 divided by 1, which is equal to 1. So for x equal to 0, I am getting this mod to be equal to 1. So there is a possibility that this mod can be equal to 1. And that possibility is when x is equal to 0. Because of this closed interval, I can take x equal to 0 and also I can take x equal to 1. So for x equal to 1, what this mod is? It is 1 divided by n, where n is your natural number, So you can get the answer to be 1 or 1 by 2 or 1 by 3 or 1 by 4, so on, for x equal to 1, right? So the maximum value for this mod is 1 for x equal to 1. That means for this closed interval, the maximum value of this mod is 1. That means, can I write the mod of 1 divided by n the power x to be strictly less than 2 for all x belonging to the closed interval 0, 1 and for all n belonging to the natural number? So writing this mod to be strictly less than 2 is valid for all x belonging to the closed interval 0, 1 and for all n belonging to the set of natural numbers. So that means what? We are getting the boundedness of Vnx. So therefore, Vnx is, because it is happening for all x belonging to the closed interval and for all n belonging to the natural numbers, this sequence is uniformly bounded on closed interval 0, 1, right? So all the three conditions for Abel's test has been proved. And when all these conditions are proved for the Abel's test, we say that the given series is uniformly convergent. Thus, by Abel's test, the given series is uniformly convergent on closed interval 0, 1. Alright, thank